All right, so I'm Josh Adams, as he said, and I'm going to explain to you, as a Rubyist, why you should give Elixir a shot. I'll do this primarily by showing you a lot of the syntax and the primitives, and I'll compare it to Ruby where that's appropriate. So at a really high level, if you've never heard of this language, who knows who Jose Valim is? Okay, so a bunch of people, right? He's a Rails core developer, very substantially known Ruby developer. So in 2011, he took a sabbatical from Rails core. And he went to work on like a secret project or something, and Elixir is that project. It's a functional programming language built on top of the Erlang VM. So to give you the official Elixir sales pitch, Elixir is a functional metaprogramming aware language built on top of the Erlang VM. It's a dynamic language with flexible syntax and macro support that leverages Erlang's abilities to build concurrent, distributed, and fault-tolerant applications with hot code upgrades. All right, so that was a bunch of stuff, right? I'm going to try and touch on all those topics, but there's limited time, so we're going to go ahead and get started. I'm not going to kick off this talk saying, hey, you should learn Elixir because I think it's really neat, but I'm not above getting other people whose opinion you might value more than mine to do it for me. So Dave Thomas, Pragmatic Programmers, he's repeatedly said that Elixir gives him the feel goods the way that Ruby did when he started learning it in 1998, which is earlier than most of us. He's seen more than a few programming languages. He kind of knows what he's talking about. And he's currently writing the book Programming Elixir, which is an introductory text for learning Elixir. All right, so Bruce Tate, anybody heard of him? 7 Languages in 7 Weeks, a bunch of other sevens books. So he points out that we're making a transition to multi-core. He goes on to say that if we don't switch to something other than mutable state, then things are going to break. And I agree with this absolutely completely. I recently built a distributed system in Ruby using Celluloid, which is very cool. But building it in Ruby was really frustrating. Celluloid is great, like I said, but Ruby libraries everywhere do really bad stuff with mutable state, typically in a not concurrency safe manner. The killer problem that I had that was the biggest one was a problem with RSpec's new mocks. But there were a host of situations where I ended up writing a library instead of using existing Ruby libraries. Like one of the big reasons for using Ruby is incredible library support. There's just libraries to do everything. But one of the downsides is none of those libraries care about threads, guys. None of them. So all the time I found a library that did exactly what I wanted to, and then when I dug into it, it did it in this horribly very bad to make thread safe way. And so I ended up rewriting them constantly. Anyway, so yeah, it's fairly understandable if you attended last year's RubyConf why that would be. Matt said last year that he's not a threading guy, which is understandable, right? We all do our own thing, but it was incredibly frustrating to me because I was dealing with all of this stuff at the time, and I was really hoping when he was asked the question that he would come up with this amazing silver bullet, we're going to put these concurrency primitives in the language, and no, we're not for a while. Anyway, so that's the Elixir sales pitch, but why am I qualified to tell you about this stuff? First off, I'm the CTO of Isotope 11. It's a software consultancy. We've been doing Ruby client work for 8 years, going on 9. And we're also very comfortable with JavaScript, Erlang, and Elixir. We've had 2 projects wrap up this week, by the way, so we're looking for new awesome projects if anybody needs help. Anyway, if it weren't for this company, I wouldn't be here talking to you, so I'm going to sales pitch it. So anyway, I also run a subscription screencast series called Elixir Sips, and for one of the best questions, I'm going to give away a subscription, so ask good questions. It basically chronicles my journey learning Elixir. And there are presently 63 videos, there's 7 hours of footage. I've been doing it for 7 months. Anyway, so this is 7 months of Elixir is a pretty long time, given how new the language is. So I've probably written more Elixir code than most people you'll run across. Anyway, so having said that, we'll get into it. In this section, there's really 2 sections to the talk. We're going to cover some basic stuff, so data types, pattern matching if you've never seen it before, functions, modules, and mix, which you can think of as a build tool / dependency manager. So let's get started. All right, so the data types we're going to cover are atoms, numbers, strings, lists, tuples, maps, regexes, and Booleans. So atoms, these are just like symbols in Ruby. They look pretty normal. They consist of a colon followed by letters, digits, and underscores. In Elixir and Erlang, atoms are used very frequently to tag tuples, which we'll get into later. So you'll often see them as the first element in a list, or in a tuple rather, and that'll be called a tag tuple. Strings in Elixir are exactly like strings in Ruby, except they're not objects, so not really much like strings in Ruby. If you saw the article on Hacker News a while back discussing Unicode support in various languages, you'll be glad to know that Elixir spanks most other languages, including Ruby, in this area. So one of the really neat things about Elixir's Unicode support is it's programmatically built at compile time based on the Unicode data.txt code points file, which is just neat, like metaprogramming in the core of the language. Integers, all right, so basic data types, right? You can see here that you can use underscores in them. The compiler will ignore them. So that's like Ruby. I don't need to tell you, but I will, that you can add and subtract them and compare them. Nice things you might want to do with numbers. Floating point numbers have a decimal point, and you can't not put a 0 in front of them. All right, so lists. So these look like arrays in other languages, like in Ruby, but they have different semantics. So writing a list is easy. You put stuff in square brackets. But due to the way they're implemented, the easiest thing to do with the list, or the fastest thing, is to get its head or its tail. So that's either like the first element of the list or all of the rest of the list. So this is because lists are actually linked lists. There are a couple of built-in functions for accessing the head and the tail of a list, HD and TL. You can see what they do. And if you want something more like arrays, then what you want is tuples. So tuples are ordered collections. They look like curly braces surrounding things separated by commas. Tuples are used frequently in pattern matching and as return values from various functions, and these two facts are not unrelated. Now, while lists are implemented as linked lists, tuples are contiguous areas of memory behind the scenes, and so they can be accessed in constant time. So this is why you want to use them if you want to deal with like big lists of things that you're going to access deeply, randomly. Anyway, maps. These are very new. They're like hashes. They only landed in Erlang in Erlang 17's first release candidate. Erlang 17 is not out yet. So as of this writing, these things don't even exist in stable Erlang, but they will really soon. In the first implementation, they're slow for using with large numbers of items. This will be addressed in the first point release, just so you know. And since Elixir is a citizen of Erlang's VM, when they're updated in Erlang, that we'll get them. Updating a map has like some interesting behavior or syntax. So first off, the syntax is really interesting. So here you can see well, first off, you can address the items, the keys in a map, either with dot syntax if they're all atoms, or with your access syntax on line 3 there. Also, updating looks kind of funny. So like you have a map, but you've got this first element is the map you're updating, and then a pipe, and then the stuff you want to update. So the next thing about them is really, I like it a lot. So this is a fun error. I tried to update a map with a key that wasn't in the map, and it throws an argument error. So this is nice. And I'll tell you why. So I had a Ruby / Mongo project before that was brought to us as kind of a rescue project. And after launching, we realized like this developer previously had run an import to migrate data from this old CMS with tens of thousands of pages to their new hotness ground up rewrite, whatever. But he had a typo in his import script. So he migrated data, let's say it's like gallery, and he missed an L. Okay, so there's a bunch of data in the wrong key. Like Mongo doesn't care. So cool, now you've got tens of thousands of pages with data that's not there. And the way the CMS worked is they showed a gallery if this key existed. So like 3 months after they launched this very expensive site that our customer had built for them, they got a call from the customer and they were like, hey, we have like 2,000 pages that are missing data, and what the hell? So anyway, we realized later, hey, this didn't work right, but that's frustrating. Like that shouldn't happen ever. You shouldn't lose a bunch of data and not know it. So this is mostly, I'm talking bad about Mongo, I think. But anyway, that can't happen here. Also, Elixir has Perl-compatible regular expressions. So you can use these just like you're used to with regexes. You use the R sigil, where a sigil is just tilde followed by a character. And Ruby uses sigils to great effect, the %, right? And so I'm really glad to see them in Elixir. They're nice and concise, and they make things pleasant. Anyway, so they're like some of the more advanced use cases of regexes are supported already. So like named capture. So this is I really like this right here, where we capture a section and we call it title, and we get back a key list that has the title key populated. You can also do like scan and all the things you want to do. In Elixir, everything but false or nil is truthy. So and false or nil are both just shorthands for atoms with the same name. So that's it for the basic data types. I don't need to spend a lot of time on that. So we'll go ahead and move on to various places you'll make use of pattern matching, which was one of the like neatest things when I moved to Erlang and Elixir that Ruby doesn't have. All right, so we're going to talk about the match operator and function definitions and case statements. All right, so the match operator is just the equal sign. It looks like variable assignment at first glance, but there's something a little weird about it. So this sets the previously unbound variable foo to the integer 1. And so that's just assignment, right? Okay. So if that's assignment, what is this? because that's valid, and that's obviously not assignment. Okay, so it turns out the match operator is an assignment. It's really more like making an assertion about the world than it is assignment. But if there's an unbound variable that you're trying to match on, then Elixir will bind the variable so that your assertion is true. And so that's what's happening there. That's why the second thing makes sense, because it's already bound, but this is true, so we can go on. Anyway, so that fails, right? So 2 is not equal to foo, throws an error. Anyway, so this is a match error, and since pattern matching was very new to me, I saw this a whole lot when I was getting started with Elixir, and you will too, and it's a normal thing. Like if a sort of unexpected state happens in your program, you're likely to run into a match error. Anyway, so we'll look at some more advanced matches to further explore how what we're dealing with is not at all assignment. All right, so can anybody tell me what this expression does? Yep, so it'll bind bar to 3. Anyway, so that's just making sure that the match is successful. All right, so if you want to match on a larger data structure, but you really don't care about 4 out of 5 values, you can use an underscore. So this basically tells the compiler, I don't care what's in the first place, but bind baz to the second element of the thing I'm matching against. So it's like a wildcard for pattern matching. Anyway, so again, this is just a signal to the compiler, and I should point out Elixir is a compiled language. It's not an interpreted language like Ruby. Anyway, that says you don't care about that value. All right, so there's one more important point in Elixir that's different from Erlang, if anybody knows Erlang, and this confused me for a little bit. So you can actually rebind variables in Elixir. So it's still immutable, but there's no static single assignment. So you can rebind a variable. And if you want to tell the compiler, hey, please don't rebind this variable, I want to actually use it as a filter, then you can just put a hat before it, and the compiler knows, okay, it's not valid to rebind this in this context. Anyway, it's a pretty decent trade-off. It's a lot nicer than in Erlang you would end up with foo1, foo2, foo3, just because you can't rebind variables. Anyway, pattern matching is used to choose between multiple possible definitions of a function. So as an example, we've defined a fairly silly function here. So this function is defined differently based on the inputs to the function. Or the pattern, rather, that the arguments match. So this is the first intensely different sort of thing than Ruby that we've seen. So I was a math major in college, and so defining a function as how it operates based on inputs is very nice, and that's how I want to think about functions. So it made me really excited. Anyway, case statements can be used for control flow, and they too operate based on pattern matching. So here you can see the middle case is what's going to match. So there's precedence, top to bottom precedence. So the third case would match, but since there was already a match, it's not going to. All right, so that's it for the basics of pattern matching, and we'll move on to functions. So in Elixir, functions are first-class types. This shouldn't be that surprising. It's a functional language. So we're going to look at defining them, calling them, and then using them as types. So anonymous functions are defined with the fn keyword. We saw that a second ago. So functions take parameter lists and bodies separated by arrows if you want to know things to call all these pieces. The parameter lists are used for pattern matching. And then, so here the print name function will just concatenate the first and last names together. The syntax to call an anonymous function in Elixir is a little weird looking at first. So it looks like this. So it looks like a normal function call, but there's a dot. The dot makes calling it feel different from calling a function in a module. So anyway, it's worth pointing out that there's discussion about that going away. I have no idea if it'll go away, but I used to hate it. I don't mind it now. Anyway, so what happens if you call this function with something that doesn't match any of the parameter lists? Okay, so it throws this kind of error, a function clause error. So this basically says, I have a function, but I don't know what to do with the thing you pass the function. Anyway. All right, so we'll define an anonymous function that behaves differently based on the argument provided. So we've got an anonymous function here, and if you give it a list of 2 items, it'll return the sum of their prices, and if you give it a single item, it just returns the price. This is, in fact, a very silly way to define this function. Recursion would make a lot more sense. But recursion in anonymous functions is not quite ready yet. So for the purposes of demonstrating pattern matching, this is what we're doing. Now you can call this function with either the single item or the list of 2 items, and it'll do what you want. So there you go. Like I said, this is low utility. I just wanted to show it on maybe a slightly less trivial example. Anyway, one more fun thing you can do with anonymous functions. Don't know how much utility it provides, but you can like invoke them immediately, right? So they're just a return value. Anyway, just wanted to show that off. All right, so since functions are first class in Elixir, you can pass them as arguments, or you can return them from other functions. So we're going to play with that. Here we've got a function that takes an argument, and it returns a function that adds that argument to the new function's single argument. So add 3 equals add called on 3, and we get an adder that adds 3 to whatever its input is. So you can think of this kind of like partial application, but Elixir doesn't have partial application. You can also write functions that take other functions as arguments. Hold on a second now. Has that said that this whole time? Wow, that's impressive. Anyway, so here's an example. We've got a greet person. It's a function that takes 2 arguments. The first is a greeter function, and the second is like a person tuple. And it just calls the greeter function with the first and last name concatenated. So then we define a polite greeter and a terse greeter, and we call them. Like, this is trivial, but it's nice to see that you can pass in functions as actual objects, not objects, things. Anyway, so on to mix and modules. So modules are the primary unit of code organization in Elixir, kind of like a class, right? Or a module in Ruby. So they can contain functions, both private and public. In this section, we're going to cover using mix to begin a new project, defining a module, compiling a module, the fact that module definitions have return values, documenting a module, and then I'll briefly cover a little tool. So Elixir ships with a tool called Mix. So Mix is used for creating, compiling, and testing Elixir projects. To use Mix to start a new project, you just type Mix new modules example, right? So this is very similar to Rails new. It gives you a project. It knows about Git. It creates a Git ignore file for you, which I think is nice. It goes ahead and makes tests. You can see that testing is first class in Elixir. Anyway, so we'll go ahead and look at this mix.exs file that it generated. So this is called the mix file, and it's just a kind of a project configuration sort of file. So like I said, this is where configuration goes. You can also define dependencies down here. Right now that's just a tuple that accepts like a dependency name and then like a GitHub location, and it'll fetch, and then it'll compile the dependency. It'll fetch its dependencies, compile them. They can be Elixir dependencies, they can be Erlang dependencies, they can be either of those that also have C dependencies, and it'll handle compiling and doing all that for you using a tool called rebar. Anyway, there's also a package manager called Hex. It's in early development, and it ties into Mix, but it's not really quite ready yet. I just wanted to show you what a Mix file looked like. All right, so here's a trivial example of defining a module. It has a single function. So it's published, it has arity 1, and obviously it doesn't do anything. It just returns the argument. It's important to recall that you can have multiple functions with the same name, and it'll just pattern match against the different the function definitions. Anyway, so now we'll see how to compile this module. That's a little bit small, but so the first thing you can do is you can just launch the module with IEX, which is Elixir's REPL, kind of like IRB. If you pass a module as an argument to it, it'll compile it and load it into that IEX session, so you can use it. The second way is by using Elixir C. So Elixir C, not surprisingly, stands for Elixir Compiler. It ships with Elixir. It can be just launched with an argument. And it'll generate a file from this called elixir.modulesexample.publisher.beam. And so that's just a beam file. The Erlang VM, this is the bytecode that the Erlang VM knows how to deal with. So you can then like just put that on an Erlang system if you'd like, and you can talk to this module from Erlang. You don't have to, you can interoperate between them. Anyway, now if you launch IEX from this directory, it'll load all the beam files in the directory, and you'll have access to that module as well. In Elixir, you can also just define a module directly in the REPL. This is not surprising for Rubyists. It's really surprising for Erlangers because you can't do that. That's like a long-standing complaint in Erlang. All right, so to see what's happening, we'll define a module in IEX. And so this is a trivial module, but it actually has a return value. So its return value is this tuple that's got 4 elements in it. The first is the atom module. The second is the actual module name. The third, this is the actual bytecode for the virtual machine that defines this module. And so this is really neat. You can like ship this bytecode over to another Erlang or Elixir node, and it'll load it, and you can use that module elsewhere just by pushing the bytecode over to it, which is, it's really cool. Like, this is not something we can do in Ruby. And then this last is just like the last thing that was evaluated in the module. It's not important. Anyway, Elixir supports module and function documentation as first-class citizens, and this is awesome. So they can be defined with the help of these things called module attributes. So these are just these things that start with an @ sign in a module. So here's the publisher module from before. We'll document it. So documenting the module is achieved by using the module doc module attribute. And it just takes a here doc, and the here doc can have markdown in it. And then documenting the function is just a doc module attribute right before the function definition. All right, so this is cool, but like, what good does it do you? You can access a module's documentation using the H helper in IEX. So here we're in an IEX session, and we ask for help on the publisher module we just defined, and it outputs it, which is pretty awesome. Like if you just have a library and you want to know how it works, you just call help, pass the library to it. Similarly, for a given function, returns the function's documentation. You can also generate this documentation in HTML using a library called xdoc that's provided by the core team. It's markdown aware. If you want to see it in action, just go look at any of Elixir's docs. I'm not going to show it for the sake of time, but there you go. All right, so that's covered the four main parts of basic Elixir, so data types, pattern matching functions, and mix and modules. And so from here, like, you've got a rough overview. We didn't cover testing. I didn't take that off the slide. You've got a rough overview of like what it looks like to deal with just the core things in Elixir, right? And kind of a syntax and tooling overview. So now we're going to look at slightly less basic Elixir. So we're going to cover list comprehensions, structs, the pipe operator, recursion, and processes. So these are mostly things that we don't have in Ruby. All right, so the general idea behind list comprehensions is to quickly create a data structure from one or more enumerables or bit strings. So we're going to look at some basic examples. So here it is. Can everybody see what's happening here? We say for x in this list, return like 2 times x. Okay, so that's straightforward. In the next one, we're just returning a slightly different structure. Finally, we're doing some filtering. So the last argument before the do block is filters. So here we're returning all the x's that are not divisible that are divisible by 2. All right, so you can also use list comprehensions to combine lists. So let's look at that. So here we're doing something kind of neat, right? So we're taking, for all the x's in this first list and all the y's in the second list, we're just combining them, right? So we end up with a list with 9 elements in it, right? So this is neat. Like we don't have list comprehensions in Ruby. They're neat. You can do a lot of like interesting things in them that you would otherwise have to do, like some eaches or maps or whatever to do. All right, so the output for a list comprehension can get more interesting. So maybe you want to generate a list of tuples showing all the combinations. That's easy enough to do. You can get a little fancy or crazy or whatever you want to call it. So let's find all the numbers based on the first 5 odd numbers and the first 5 even numbers where the product -1 is divisible by 9. Like, okay, so contrived example, but there you go. It's pretty readable. And this made me really happy. Like, it's kind of straightforward. Anyway, this is a pretty comprehensive use of the features provided by list comprehensions. There's this thing called protocols that I'm not going to go into. You can actually do rather neat stuff by kind of hacking on the protocol that implements this, but that's way past this talk. All right, so let's go a little bit further. We'll build a module for building a deck of cards. So this shouldn't be that confusing, right? So we've defined the suits, we've defined the values, and then for all the values and all the suits, return a card tuple. This just makes me happy. It's very, very readable, and it's useful. I love the way this reads. So next we're going to look at structs. All right, so structs are like typed maps. Think of it like, well, first off, you can define a map with default values for keys. So like if you ever use value objects in Ruby, these are like excellent corollaries to that. But they can also be pattern matched against, which is powerful. So let's look at it a bit further. Structs are easy to define. You just define a function on your module named _struct. I learned recently this is called dunderscore, which makes me happy. If anybody wants to, you've learned something. Anyway, so here we've defined this function called struct. There can only be one of these defined per module. And down below you can see we've instantiated the sum struct. So it's like making a map, but you shove the struct name between the % and the map. So behind the scenes, a struct is just an Erlang map with the _struct key set to its module. So you can see here that those are identical, right? I just made a map with the _struct key. Anyway, Elixir was made for programmer happiness just like Ruby, so we're not going to be defining _ methods today. Actually, Jose wouldn't leave us with that ugly syntax, so you actually use the defstruct macro in practice. And behind the scenes, it's just doing what we did before. But this is just an example of how macros make life easier. I should also step back for a second and say, in Erlang, there's not macros. You don't have this option of macros. There's a few reasons for this. But what you have in Erlang is, what's it called? Of course, I've forgotten. Anyway, but you have to do manipulation on ASTs that vary depending on which state of the compilation process you're in, which is just horrid, and no one does that. Anyway, so that's one of the big benefits of Elixir is you get these macros. All right, so you can also see how you might define inside a module functions that know how to operate based on the struct. So this is a common pattern. You define a struct, you define functions that know how to deal with that struct in the same place. This is almost like an object in that you have data and behavior living in the same code file at least. Anyway, you can use the map update syntax to update structs, and it gives you a verification that the data that you're updating is a struct of the appropriate type. So here you can see we've updated the person struct with the new last name, but then we try to update just a raw map, and we say to the compiler, this is a person struct that I've passed you, and it says no, it's not, dummy. So I'm not going to do that, and I'm going to throw an error right here. So that's nice. This is where the sort of quasi-typing of the structs is nice. It's like if you had a hash, but that would make fun of you if you passed it the wrong type of hash. Anyway, so it's easy and convenient to pattern match on structs. So here's an example. We've defined a function that knows how to deal with people differently. So if it's your brother, because his last name's Dudington, then it'll say, hey, cool, I know you. And otherwise, it doesn't know you. And so this is just to show you what pattern matching on a struct looks like. So, and then down here we call it. It's pretty trivial. You can also just verify that a struct is of the appropriate type by passing it just a portion. So if you just did the person struct with nothing inside of it, it would pattern match against either of these guys. So you can use structs actually to do polymorphic dispatch. So if you're looking for something that lets you treat things differently based on the type of data you're passing into it, that's very similar to I don't know, something. There are very many patterns in Ruby where you want to handle things differently depending on what they are. All right, so we'll look at the pipe operator. I think it's really cool. It's used to quickly and easily create a pipeline of functions. This is a very common thing to do in a functional programming language and also in Ruby. So in Unix, a pipeline might look something like this. So here we've listed out the processes. We've grephed the resulting lines for the string vim, and we've printed their PID because it's the first column in that output. There may be better ways to do this, but this works and it's pretty comprehensible. So the reason Unix has a means of doing this at all is that piping the output of one program into the input of another is an extremely powerful thing. It makes it very easy to do composition, right? Anyway, so this is most of what functional programming is just transforming data as it goes through a pipeline. So you'd expect the pipe operator to be pretty useful, and you'd be right. And for the record, Elixir cribbed this from F#, but in F#, it's actually implemented as partial application, and in Elixir, it's just syntactic sugar for a common pattern. So in Elixir, all the pipe operator does is it takes the output of the expression on the left of it, and it feeds it in as the first argument to the function on the right of it. And what it's really doing is it's calling a function with the arity. So if you call a function on the right of it that takes one argument, you can imagine that what you're really doing is calling a function that takes two arguments, and the output on the left is going in as the first argument. Anyway, so I'll stop talking. We'll look at it. So this is the pipe operator. It's the pipe plus the greater than sign. So I had somebody previously ask me, okay, I get the pipe, but what's this other thing for? And so I didn't explain. That is the pipe. So this is a code from a little project I put together to provide an Elixir-esque version of the Unix pipe example I just showed you. So it looks almost identical to the Unix pipe example. If I'd imported the Unix module, then I wouldn't have had to say it every time. Anyway, so with this pipeline, it's pretty easy to see what's happening, just as easy as it was in Unix. So here would be the same pipeline, but unrolled. So if we weren't using the pipe operator, it would look like this. I really hate how the argument to awk is on the far side there, right? Awk is the first thing I've called, but the argument's way down there. So short of spreading this across multiple lines, there's no really trivial way to make it clear to someone without them counting parens what they're looking at. And I just think this is way worse than the thing up top. So this is just another example of how Jose is with Elixir. He's doing the whole created for programmer happiness thing. He's spending a lot of time trying to get syntax right so that our code is readable and our code is nice to write. Anyway, so with that said, let's talk about recursion. Okay. So we're not going to talk about it a ton. I just want to cover it briefly conceptually because you can do things with recursion in Elixir that you cannot do in Ruby. Recursive functions call themselves again. To show this off, we'll just write a recursive function that can sum a list of numbers. Anyway, so here's a basic recursive function. It's expected to be used in the first form, and then it's got these two. Defp is a private function that you can't call from outside the module. So you call it in the public form, and it uses these other two. So internally, it calls it second form, which takes a list and an accumulator, and it defaults to the accumulator being 0. And the accumulator is just going to be used to sum up the accumulation as we squash down the list. Anyway, so what it'll do is it'll pop this pattern match that has next pipe rest. It's just grabbing the head and the tail on either side of that pipe. And so all it does is it calls itself on the rest of the list and passes the first argument in the list, or the first element of the list, as addition to the accumulator. And then finally, we have the pathological state where you call some list and your accumulator is empty. Your input list is empty. Then you just return the accumulator. So this is your traditional recursive pattern, right? Anyway, so these are really all the core principles that are involved in recursion. Like before I got into functional programming, recursion was this like kind of weird thing to me because I knew like I can't do it in Ruby because I'll blow the stack. So it's important to point that out. Like Elixir actually has tail call optimization because Erlang does. So all that means is if the last expression in a function is a recursive call to itself, it's not going to require an increasing stack size to handle the calculation. So if you try to do this type of recursion in Ruby, you'd run into Stack Overflow errors anytime you gave it a big list, and there'd be a new frame on the stack for each like iteration of the recursive function. And then you can still do recursion in Ruby, but depending on your context, your stack size is different. So like fibers have a different stack size than threads, and so that's awkward, and you'd have to know these things. Anyway, so we'll go on to processes. So here I'm going to quickly cover what they are. We're going to play with them a bit. And we're going to look at encapsulating state in a process. So let's get started. So Erlang is a concurrency-oriented programming language, and so consequently is Elixir. Its unit of concurrency is the process. This has nothing to do with an operating system process. If you've heard people talking about the actor model, this is ultimately what they're talking about. So processes share no memory with one another, and they can only communicate with each other via asynchronous messages. And anytime you send a message to a process, it's a copy of the message. So you're never actually sharing anything between them. It's a shared nothing architecture. They're also each independently garbage collected. So there's never, in Elixir, there will never be a stop the world garbage collection like you'd have in Java or Ruby. And also, just real quickly, these things can never block one another. So the way that Erlang VM's scheduler works is that each process in the system gets 2,000 reductions before it moves on to the next one. And so 2,000 reductions is like real fast, right? We're using fast processors. So it's completely normal to have a million of these things in a system. This is not going to slow your system down. You could never run a million threads on a machine. These are not threads. These are very, very tiny things. They use very little memory each. Anyway, so also by default, if you use a lot of processes in your calculations or in your system, which you're typically going to do, it'll run multi-core by default. You don't have to do anything. Erlang spins up like say you have a four core machine, Erlang will spin up a scheduler on each core, and then it'll distribute the processes amongst the schedulers so that each core is doing as much work as it can possibly make it do, which is nice. I have kind of a sort of example. So there are a lot of like web frameworks for Elixir and Erlang, and so I did just a really basic performance test against one. And doing a pretty basic thing that just rendered a template, took an argument out of the URL, and then like modified the template with it. I was able to get 40,000 concurrent requests with 0 actual optimization. So like doing the same thing in Ruby, you're 300, right? Doing the same thing in Node, you get like 8,000. The reason for that is because it's only using a single thread. So this is just like without doing any extra work, you get to take advantage of your full machine. You also could take advantage of multiple machines. So Elixir and Erlang have this concept of distribution built in. So you can add machines to a network, and up to a certain point, it's around 15 or 20 machines, your system will increase in performance linearly, which is awesome. Like this is not a normal thing you can do, right? You have to architect around that sort of thing. Past that, you actually, so if you have a really, really big system that's going to need more than 15 nodes, you probably want to actually spend some time like with queues and figuring out which portions of your system should be decoupled. But that's pretty awesome. You can go up to 15 machines in your network and just linearly increase in performance. Anyway, All right, so back to the discussion of processes. Here we've defined a new module called ping. So there's a single function in this module called await. When await is called, it blocks waiting for a pong message to come into it. Once it receives that message, it sends a ping message back to the sender, and the sender had to provide his own process ID or PID. So he had to identify himself. So next you can see we've spawned a new process, and we've gotten its PID out of the spawn link function, which is built in. Anyway, so it's important to capture the PID. This is the only way that you can talk to the process. This is how you send messages to what's known as a mailbox. So like in the actor model, you have processes, and then they have a mailbox, and they pull messages out of their mailbox at their leisure. Anyway, so then we send 2 Pong messages into that PID's mailbox, and then we flush flush is just a way to say, like, show me all the messages this process has received. You might use it in the terminal or in the console. And you can sort of see that we got 2 ping messages back. So, okay, this is just a thing that will constantly respond to Pong messages and send you pings. Anyway, like I said, you can spawn these processes on other machines in your network. So there's really no difference in the way you use it if you're spawning a process locally or if you're spawning a process on some other machine. So for instance, like I spawn processes on Raspberry Pis that are sitting on remote control tanks and use those processes to control motors on them. This is neat, and it's not at all like weird. It's just built in. Anyway, so this is just really awesome. This is a really big thing, and it's until you get like very comfortable with it, it might not be clear how big it is. Anyway, so if everything's immutable in Elixir, because it's an immutable functional language, how would you model mutable state? Like, the world actually does consist of things that can be mutated. And so again, the answer to this is processes. So with a really small tweak to what we did just before, we can build an object that can have a value that's incremented and decremented. So this is like an object with an instance variable, right? And then the actual messages you're sending are very much like sending your calling methods on objects in Ruby. I mean, we know that we send messages to objects in Ruby, right? So you're doing the same thing. You're sending a message to this object. All right, so like I said, looking at this code, you can see current value. You can think of that as like an instance variable. So this await will receive one of 2 possible messages. If it gets an increment message, it will increment current value. If it gets a decrement message, it will decrement current value. And then it'll call itself again with the new value. It'll also output it so you can see its state changing. And so then on the right, you can see we've spawned it, we've sent it increment and decrement messages, and its state changed appropriately. So this is this is modeling state. This is how you do it. Anyway, for what it's worth, there's a pattern for this sort of thing in Erlang. It's called a gen server. And there are also macros in Elixir for building these things more robustly and more succinctly than I've done here. So all I wanted to do here was show you how to deal with this using the underlying primitives that the core language gives you. But you'll want to, if you play with Elixir, you'll very quickly get into OTP, which is this whole framework for building these distributed fault-tolerant systems. And gen server is like the introduction to OTP. Anyway, so that's it for processes. We covered how to spawn them, how to communicate with them, and we learned a pattern for encapsulating state in a process, and this is one of my favorite tricks. So to recap the section, we covered list comprehension, structs, pipes, recursion, and processes. So this is the core of like the introductory stuff. There are a few things that I don't have time to cover, but I wanted to, or I think are like the important next steps, so I'll give them speedily. Testing, Elixir ships with XUnit. It's built-in testing. It's really great. Think of it like test unit, right? There are also doc tests, which are amazing. They were absolutely cribbed from Python, and Ruby should do that. So they can verify that the examples in your documentation aren't lying. So imagine everybody knows, like in documentation, you see like, here's how you use this thing. You call like add on 1 and 2, and it returns 3, right? But have you ever read documentation where it says that and then it doesn't work that way, like all the time? So it's a one-liner to add a test that verifies that your IEX sessions that you've pasted into your documentation are still true. So that's a really awesome feature of the language, and I wish more languages did that. I mentioned OTP. It's really the next thing to go to after processes. It's an encapsulation of various common patterns that people have built over like 25 years, building very large distributed fault-tolerant systems in Erlang. And you'll ultimately want to build your apps to be OTP compliant, because you can then best take advantages of all the other libraries available that know how to interact with OTP apps. Let it crash. So this is this philosophy. This is what gives Erlang applications and Elixir applications amazing uptime performance characteristics. So basically, you build your application in a supervision tree that knows how to, like every piece basically knows how to spawn from scratch the next piece down the chain in complexity of your system. And if any piece in your system ever fails, like say maybe you have a portion that knows how to communicate with GitHub and GitHub gets DDoS, not like that ever happens, then all of a sudden like all these calls are going to start failing. So like you could imagine having a bunch of rescues throughout your code that know how to handle that situation, but realistically all those rescues are down to the same problem, which is GitHub went away. So if you have a system, if you have a portion of your system that is the GitHub communicator, it will basically go down and try to bring itself up until GitHub comes back up. And so that's what like supervision and let it crash means. And then you might imagine like you try 4 or 5 times and GitHub doesn't come back up. So maybe you have to restart like this other portion of your system. And so you can imagine the supervision trees like crashing all the way up. But that's a good thing. It helps you get really, really high uptime, sort of paradoxically. Distribution, this is where I mentioned that processes don't have to be on the machine that you're working on. So imagine this is like DRB on steroids. It's like DRB is part of the standard library, but it's not part of the actual core language constructs, whereas distribution in Erlang is absolutely like one of the most fundamental primitives possible. And the ponies were a lie.